My name is Donald Glover. I'll be talking about the fundamental theorem of calculus and initial value problem. Please excuse my screen, just a little messed up. So, what is the FTC? The FTC, or the fundamental theorem of calculus, states that if f is continuous on a closed interval ab, and f is the indefinite integral of f on ab, then integral a to b f of x dx equals f of b minus f of a. Again, integral a to b f of x dx equals f of b minus f of a. The second fundamental theorem of calculus holds for f, a continuous function on an open interval I and a. Any point in I states that if f is defined by f of x equals the integral a to x f parentheses t close parentheses dt, then f, which you see a little subscript up top, which is just basically just derivative, f derivative of x equals f of x at each point in I. The fundamental theorem of calculus along the curve states that if f of z is a continuous and definite integral, f of z in a region R containing a parameterized curve, then the integral y f of z d to z equals f to z of beta minus f z to a. So, what is the initial value problem? And the initial value problem is in the field of differential equations. Initial value problem is an ordinary differential equation together with a specified value called the initial condition of the unknown function at a given point in the domain of solution. So the question I chose was question 82 on page 340, and that question asks final linearization of g of x equals 3 plus integral from 1 to x squared, excuse me, secant t minus 1 dt at x being negative 1. So, start off, write down your problem, write down g of x equals 3 plus the integral of 1 to x squared secant, parentheses t minus 1, close parentheses dt, what you see is right here. Then you go down 1, you get rid of 3 because it's a constant, and you have your answer, which you have right here. All right. Then when you move down, you flip the upper and lower limits with each other. You always flip those if there's a negative sign. So you see a negative right here, you flip it, and you put the negative front. The one right here goes up top, negative 1 squared goes down the bottom, what you see right here. And I wrote the formula out so you can see. Let's zoom in a little bit better so you can see. All right, then moving on next, you'll take the denominator of secant t minus 1 and compare it to 0, which we did right here. And then you move down and you get, this is your answer. So you have negative 1 squared is less than t, and t is less than 1. Therefore, t must be equal negative pi plus 2 over 2. Which is the answer right there. Then you get your answer below, which you can see right here, which is right there, which is the formula that you're supposed to use, which is from the above one, which is this right here, and we're using it right here. All right, and when you move down, you apply U substitution. You get equals integral of negative 1 squared to negative pi plus 2 over 2 secant t minus 1 dt. Then you move down again. U substitution, as you can see, u du is right here, u du. And then your answer is right here. You use the common integral. integral secant of u du equals ln tan u, let's say u, plus secant u. All right, and then the solution in the next page right here. Close brackets, you have ln tan u plus secant u. On the outside, you have negative pi plus 2 over 2 minus 1 and negative 2 at the bottom. And your final answer will be 0 or undefined. The bonus problem. So we have y equals integral of x to 5, 3t sine t dt. So you're going to find dy of dx, which equals d over dx, integral x to 5, 3t sine plus t. So you're looking for dy dx. You bring it down right here. You bring the negative in front, d over dx, parentheses next, and parentheses negative sign, integral x 5, 3t sine dt. You flip the upper and lower limit, which we did again, as you bring the x to the top and the 5 to the bottom. After that, you bring the negative to the front, which you see negative d over dx. You have x and 5 on the bottom, x at the top, 3t sine t dt, which your final answer will be negative 3x sine x.